Good afternoon, everyone, and welcome to Jaxon's weekly Deminar series. My name is Jose Cantu, and I am the Director of Defense and Intelligence here at Jaxon AI. Today, we're going to be going over a product overview and a demo of how Jaxon uses neurosymbolic guardrails to test data inputs, either human or AI generated, to ensure compliance against organizational policies, guidelines, regulations, etc., using LLMs while eliminating hallucinations. Jaxon, for those that are not aware, is an AI startup focused on making your AI tech stack trustworthy and usable for high rigor, high value, mission critical workflows. Founded in 2019, Jaxon has deep experience in the AI and machine learning space, as well as a talented team developing these capabilities ready for deployment within your enterprise. So jumping in, we continue to see a problem with AI technology. Gen AI and agentic AI solutions in particular at this point are commonplace, and they're extremely impressive in their capabilities. Most recently, OpenClaw made a big splash, right? That's just the latest in a long line of capabilities that have caused a paradigm shift in the AI market. However, from the rollout of ChatGPT to the deployment of RAG systems to enterprise chatbots to the rollout of agents to now OpenClaw, the common theme remains a fundamental question of trust. Lack of trust, driven by the constant anecdotes of AI going off the rails, continue to prevent enterprises from enabling the use of AI on their high-value workflows. The core of the issue is that LLMs are probabilistic systems that predict the next token/word in a sequence based on the patterns that they've seen in their training data. So none of this is grounded in fact. It's just a prediction of what the next word, what the next token is going to be. So LLMs just lack the ability to cognitively reason through specific workflows that require that higher fidelity that's required for enterprise adoption, for those high rigor, mission critical workflows. So we've seen over the years a number of solutions, right? We've seen reasoning models, we've seen LLM wrappers such as RAG, retrieval augmented generation, and other methods such as LLM as a judge that have attempted to bridge the gap, that trust gap. They keep falling short. RAG does a great job at retrieving accurate information and providing the LLM the context to return, quote unquote, an accurate answer. However, it doesn't necessarily increase the rigor applied to each answer because it relies on a fundamentally probabilistic system to process it. So I'm sure everyone has encountered this issue at some point or another. Like when you submit the same prompt and the same context twice, and the LLM delivers an entirely different response for each submission. Both responses may be accurate, but they're entirely different responses. Or when you prompt the LLM with something like, read this document and answer these 10 questions, but it only responds to 6 of the questions. Though RAG provides that correct context, the core of the issue remains that the probabilistic nature of the LLM precludes the ability to add the rigor to the answers that are needed. So you're beholden to the unknown probability of the LLM answering all 10 questions or even answering in the same way twice. So methods like LLM as a judge and knowledge graphs also do increase the fidelity of responses by providing additional checks, by providing higher fidelity of data. But at the end of the day, these systems are probabilities on top of probabilities, leaving the user without a way to guarantee consistency, completeness, correctness, and clarity, which are the 4 keys to trust in AI systems. So the reality is that just current systems leave us with a lack of operationalization of AI in higher rigor, high value mission critical workflows. This is just unacceptable to enterprises, right? The enterprises can't trust their AI systems for compliance. They can't trust them for multi-million dollar decisions. They can't trust them in national security for use cases for use cases in life and death situations. Even if there's that chance of getting it wrong, you can't trust it to execute. So the solution here is Jaxon. Jaxon is on a mission to unlock the value of AI for both businesses and for national security organizations. Jaxon is an AI driven verification and validation tool for those high rigor, mission critical workflows where you need consistency, completeness, correctness, and clarity. Jaxon does this by extracting explicit rules from relevant policies and regulations and then evaluates your data against every single one of those rules and policies to ensure that compliance. Jaxon uses a hybrid neurosymbolic approach to evaluating your data through a deterministic reasoning engine that applies the extracted rules to mitigate the probabilistic nature of the LLM and ensure that accurate, repeatable, human traceable, and auditable response every single time. Uh, Key here for folks working in national security, Jaxon is able to deploy in a variety of manners, including on-prem, in cloud environments, and even on edge in DDIL environments. We can also deploy integrated into your existing stack or as our own standalone solution. So Jaxon's key differentiator here is our ability to bring in your organizational policies, guidelines, regulations as coded rules together with symbolic reasoning and formal methods to return that deterministic answer every single time. We've even seen within enterprises and national security organizations that they've tried to, retrain a model with their internal internal data sets to, again, provide it that additional context. But even workarounds like that are missing that ability to encode the specific rules, right? You're providing the model additional context, but it's missing the ability to go through deterministically to make a determination on each specific rule. So here's where we get into verification and usage of Jaxon. So the Jaxon platform operates on two independent steps. The first is configuration, where you create the guardrails from your policies, guidelines, rules. And the second is inference, where we actually enforce those guardrails on the data that you submitted for processing. So Jaxon starts off in that configuration step with your organizational policy documents right down here, your policies and your SME input. So say for national security use cases, that can be adjudication guidelines for clearance processing use cases, which is what we're going to cover in today's demo. For procurement use cases, it could be bringing in a specific section of the Federal Acquisition Regulations, the FAR, or the Defense Federal Acquisition Regulations, the DFARs, so that you can process your procurement packages. Or the third, for a security classification use case or an automatic classification use case, we can bring in security classification guides or SCGs to process data through them at inference. Oops. So we process these documents. Once we bring them in, we process them through an LLM to extract a set of questions that are to be converted into code that will be used to evaluate the data when we actually submit it in for inference. So this is where we actively encourage SME input or subject matter expert input to ensure that human on the loop validation, that the guardrail is configured correctly. So once we have a policy configured, we can actually start processing the data during the inference step. So this can be again, a procurement package, it can be an adjudication package, it could be emails, it could be other communications, documents, et cetera, et cetera. But the key here is that we're processing that data that needs to comply with a set of policies, rules, regulations. So we take that data for evaluation and then process it iteratively with the LLM to check the data against every single one of those policies, rules, and guidelines that we codified in the configuration step. The results here are then processed using formal methods to generate a deterministic result. So that's right here. This is Jaxon's secret sauce, our domain-specific AI logic. And this returns answers to tell you whether this document or this piece of data is compliant, yes, not compliant, or unknown. Very, very importantly, we surface when items are unknown. Their compliance is unknown with that specific policy, rule, or guideline. So, in addition to that rules determination, the extracted data and logic applying to that data is then exposed via API to provide an audit trail and explanation for every single one of those determinations made by the Jaxon platform, by DSail, to give you that full compliance audit and full trust in every single one of the answers provided. So say, for example, in a clearance adjudication use case, say that the policy states the subject should not have a declared bankruptcy in the last 7 years. Jaxon would, one, bring in that policy, turn it into a rule, and then from there, say that the data that we submitted for review says the subject declared bankruptcy last year. In that situation, Jaxon would return, yes, this person declared bankruptcy in the last 7 years. In the second example, say the data said subject declared bankruptcy 10 years ago. In that situation, Jaxon would return, no, the subject has not declared bankruptcy in the last 7 years. In the third example, say that piece of data says the subject has $150,000 in credit card debt. While that may violate a different policy, for this one in particular, Jaxon would return an unknown. The data provided to check against this particular policy did not have the context necessary to make a yes-no determination on compliance. So that's how the Jaxon platform works. I understand not necessarily everyone on the call may be familiar with the underlying technology, definitely way more familiar with RAG systems, with LLMs by themselves. So in order to help frame that, the conceptual understanding of Jaxon, we ended up running a benchmark recently comparing Jaxon capabilities to a variety of LLMs enabled with RAG, or retrieval augmented generation, to determine differences in performance when evaluating a policy document against data inputs for evaluation. So in this case, we used the SEED 4 security clearance adjudication guidelines and a mock adjudication package for a subject being evaluated for clearance suitability. The intent here was to determine which system was more consistent, correct, and clear. So after processing and doing multiple runs, I believe it was 10 runs for every single one of these packages, our findings identified that LLMs plus RAG are, one, inconsistent. Over multiple runs, LLMs and RAG returned different results between 50 and 20% of the time. So as you can see here, we evaluated GPT-5.2, GPT-04 Mini, and Gemini 3 Pro. So in that consistency, right, this is the difference in multiple runs. So in run one, this GPT-5.2 may have said this is passing. In run 2, it'll say this is passing, but run 3 says this is not passing, right? That inconsistency leads to not being able to trust your AI system for those high value workflows. Jaxon's responses, because they're as close as possible to deterministic as we can get, were consistent every single run. Second, LLMs plus RAG tended to be incorrect. So LLMs tended to respond with accurate answers only about a third of the time. So in these, we provided ground truth data that we need the answer based on human determination. So again, in that example of has the subject declared bankruptcy in the last 7 years? LLMs plus RAG often returned inaccurate answers because usually they were unable to identify the unknowns. So in the third example that we covered earlier, user has $150,000 of credit card debt. LLMs plus RAG tended to provide a yes/no determination instead of flagging that they could not make a determination. Third, these systems tended to be unclear. LLMs do not provide a logical trace for why a certain decision was made. So when you submit a package for evaluation against 10 questions, these systems provide answers, but they do not provide a way to determine why an answer was provided. It just spits out the answer. Only Jaxon here, again, because we're making that API available with with our domain-specific language code, only Jaxon allows you to logically trace every single one of these decisions. So from here, we're going to jump into a very quick demo. We're actually going to cover the Seed 4 adjudication guidelines. And just so everyone is aware, this is the Security Executive Agent Directive for National Security Adjudicative Guidelines. This is an unclassified document laying out the specific guidelines that all folks submitted for clearance suitability are evaluated against. So for today's demo, we're going to be covering on the alcohol consumption guideline. So again, this is a human written policy for human consumption, for human evaluation. We're going to turn this into a machine readable set of guardrails so that we can then evaluate the data for input for compliance against every single one of these conditions. So just very quickly, alcohol related incidents away from work, alcohol related incidents at work, habitual or binge consumption of alcohol to the point of impaired judgment, right? These are the things that we are going to test for in a sample adjudication package. So let's jump on over to the Jaxon platform. So this is the developer interface for the Jaxon platform. We're going to dig into our Seed 4 adjudication application. So here, this is our big picture application that has all of our guardrails built into it. Specifically, we have in this one built out the financial considerations, the alcohol consumption, and criminal conduct guardrails. And this is just our direct acyclical graph, which gives an understanding of how the data is being processed. So when you submit an adjudication package, you see that we're going to evaluate it against every single one of these guardrails to give you that final result. So jumping in to the particular guardrail of interest, we already did the configuration, but I'm going to walk you through how we do the configuration here. Let me just find the alcohol consumption Seed 4 guideline right here. So The way that we process a guideline, such as seed 4, into something readable by a machine to set it up as a guardrail, we actually bring it into the guardrail configuration page. So here we select our LLM, we drop in the policy that we want to turn into a guardrail. So here, alcohol consumption, this is just copy and pasted the concern and specific conditions that we just covered in the seed 4 document. We then prompt our LLM to do the extraction of every single one of these rules into a machine readable rule. So here we have the off-duty alcohol incidents. We can actually click into the rule and we see the code. This is that domain-specific language that we create from every single one of these guidelines to start checking our data package once it's submitted. So we see that we're going to search for police records indicating off-duty alcohol incidents. We're going to look for witness statements indicating off-duty alcohol incidents, and that's the data type that we're going to evaluate. So Boolean, yes, no's, year of incidents that these happened, integers, etc. And then here we have the specific questions that we're going to have the LLM ask of that data package to make a determination on that code, on the variables in the DSAIL code. So here, do the police records indicate an off-duty alcohol incident? Do witness statements indicate an off-duty alcohol incident? What was the year of the incident? The goal here really is to turn a full evaluation into a series of micro tasks, turning it into something that LLMs are really, really good at, right? So the difference, going back to our RAG benchmark, with RAG and an LLM, you submit a 10-page packet and these 5 questions that we're going to evaluate. And you say, here is this packet. Now answer these 5 questions, right? Then it all goes into a black box. We get a returned result, but no ability to do any of those checks, no ability to make a determination or have the logic behind why each of those determinations were made. This is Jaxon's key differentiator, right? We're not relying on the LLM to do the reasoning, to fully answer, here's the document, answer these 5 questions. We are leveraging it to answer individual questions. This is how we're able to add that rigor. This is how we're able to ensure that every single one of these questions is answered and answered correctly every single time. So now that we've processed that seed 4 guideline, now that we have it as our DSAIL code, now that we've set up our proper review questions, let's go in to our playground. Again, this is our development environment or our developer view to start testing that alcohol consumption guardrail. So here, let's select our alcohol consumption guardrail informed by seed 4 adjudication document. We'll just select our latest version and let's drop in the context. So this is the data in portion. So I have a sample nomination package for our purposes. We're just going to go to the reported alcohol consumption interview notes. So for everyone that has a clearance that's on today's call, you are familiar with how the process works. You go and receive an interview, you go to an interview by a background investigator. They write up the notes and roll it up into the adjudication package. So here we have a sample notes from that background investigator's write-up. So source met the subject when they were in tech school. The source says that the year progressed, the subject's behavior was becoming increasingly erratic and concerning, particularly in relation to excessive drinking. Subject often appeared intoxicated during work hours and social gatherings, slurring speech, displaying mood swings ranging from irritability and despondence. So let's take that sample input and go back to the Jaxon platform. Let's submit it as our context to evaluate it against that alcohol consumption guardrail. So let's submit and we'll give this a second to run. But what's going on in the background is we're processing every single one of those questions in the guardrail that we already configured and evaluating each question against that data input to return not just an answer, but then evaluate that through the platform, through our deterministic or through our logical solver, and return a full answer for every single one of these rules. Here you have the proofs. So was there an off-duty alcohol incident? This was a violation. It was reported that the witness statements indicated that there were indeed issues of concern. Here, again, importantly, Jaxon does not make a determination if the data was not there to support it. So do the police records indicate an off-duty alcohol incident? We actually did not submit any police records. So in this situation, Jaxon is returning an unknown. It cannot make a determination on whether this particular part of the policy was violated. Again, off-duty alcohol impairment, we have an answer for this one. Yes, there were reports. Yes, it was confirmed that this person was drinking while on duty. And do we have evidence of treatment? We also do. And here we have that full, the patient was not following the treatment plan, but the point here is that you have that full validation, the full traceability for every single one of these questions, every single one of these guardrails to ensure full compliance against every single one of your organizational policies for every single one of your data inputs. So that about concludes today's conversation on an overview of Jaxon capabilities as well as a demo of the Jaxon platform. Thank you all for joining today. Really appreciate your time and looking forward to continuing the conversation. Please don't hesitate to reach out. My email is Jose, Jose, @jaxon.ai. Thank you and have a good afternoon.